Good morning, Math 6 students. This is Mr. Giamini. I have access to my active slate, and I am excited. I'm going to go through the evening practice or the classwork from yesterday. Should you have any questions? We're talking surface area here. Now, I always think about surface area as when I'm wrapping a Christmas gift or a birthday gift, which I don't do a lot of because, as you know, I don't really get into that stuff. But if I were to give my daughter a gift on her birthday, I guess I should wrap it. So here's what we need to do. You had to do the odd problem. So we're looking right now at the top part here. We're looking at 9, 11, and 13. Now this is nice because it gives us 3 different shapes. We have a triangular based prism, or triangular prism, excuse me. And again, it's called triangular prism because this triangle and this triangle are parallel to each other. They'll never touch. And they are congruent. They're the same size and shape. This is a rectangular prism, rectangular base that are parallel. And this is a cube. Easiest of these 3 are the cube. The probably most challenging one is number 9, which is the triangular prism. Let's start with the hard one. Let's eat our frogs first, as they say. Get the hard stuff out of the way, and we'll work our way to the easy stuff. Now, I'm going to do my best here to try to draw this shape as a net. So if I were to open this shape up and unfold it so that instead of this being a polyhedron, which is a fancy word for 3-dimensional shape, we now are going to have a net. It would look something like this. So I'm going to fold out this triangle. I'm going to have this be the back side, if you will. That's this side here. I'm going to fold this triangle out. And I apologize, my drawings are probably not going to be perfect. Here is what you would call the bottom of it, right in here. And then this is that big, if you want to think about it as a ramp. There's the big ramp part. All right. Now, what I have to be careful in, so this is what it looks like as a 2-dimensional shape. I'm going to go ahead and label these different dimensions. I can see that this little piece here, that bottom of that triangle, where we have that perpendicular piece, that is 3. Now, where this back, where again it's perpendicular meaning it forms a right angle, that's 4. That means this is 4 here, this is 4 here, this is 3 here. I'm going to label all of these dimensions. Now, also, if I focus here, there is what we call the hypotenuse of the right triangle. It's the piece opposite of the right angle. That is a 5. All right. Now, here's where I have to use my visualization skills, if you will. I can see that this here is 6. That means this is 6. And now these are all 6s here. All right. All those are 6 because all of them here, here, and here. And I probably should change the colors. Let's do that. That'll probably help us out a little bit. Well, let me get my 6s back. There we go. Let me change the colors here. So here is my 5. And that's a 5. Okay. Here's the 4, which matches with this 4 over here. Here's the 3. Okay. Now the rest becomes 6. That would be a 6. This would be a 6. And this would be a 6. Now you can see that I actually have 4 6s on this because when this folds down, if you will, if this folds down or folds back, that top part's a 6. Now, essentially I have 1, 2, 3, 4, 5 faces. I have 5 faces on this shape. Now I have dimensions for some of these that are not yet labeled. And now let's take a look here. This part here, we don't have a dimension for this part, which I would need to find the area of this. So this little piece here, I think about it, when this triangle folds in, it matches with this. So this is a 3, this is also a 3, this is a 3. Here comes a tough one. When this folds down, if you want to think about this ramp folding down, that ramp lays right here. That ramp is a 5. So this part here would be a 5. All right. Now, I'm going to go ahead and label these different faces. Face 1, face 2, face 3, face 4, and face 5. We're trying to find surface area. I'm going to put surface area equals. I'm going to make it, this may seem complex, but I'm going to walk you through this. It's going to be equal to face 1, the area of face 1, plus the area of face 2, plus the area of face 3, plus the area of face 4, plus the area of face 5. All right. Now let's look at face 1. Looks to be here, I'll call this face 1. Looks to be a rectangle that is 5 by 6. It is the area of 5 times 6. I'm going to put that in parentheses. We're going to add that. Let me change that color actually. We're going to add that to the area of face 2. Now let's go back to the illustration. Here is face 2. Here is face 2. And the dimensions for face 2 are 4 by 6. So plus 4 times 6, close parentheses, plus the area of face 3, which is down here at the bottom. Face 3 looks to be 6 by 3. So we got plus 6 times 3. I'm running out of room here. Now, we have area 4 and 5. They're exactly the same. They're exactly the same. And they're triangles. And we know triangle is 1/2 base times height. So it becomes plus, I'm going to put this in the bottom here so you can actually see it, plus 2, because these are congruent and they're the same. So plus 2 times 1/2 base times height. Now remember, height and base are perpendicular with each other. They form a right angle. We don't need the 5 for the height or the base. We need the 3 and the 4. So plus 3 times 4. Okay, that is the tough part. Now we could do this calculation. You could do this math, the rest of it, pretty fluently, I hope. 5 times 6 gives us 30. Plus 4 times 6 gives us 24. Plus 6 times 3 gives us 18. Plus, now let's try to do this together. 3 times 4 is 12. Half of 12 is 6. 6 times 2 gives us 12. All I'm doing is finding the area of every single face, surface area. Finding the area of every single surface on that three-dimensional shape, and then combining them, adding them all up together. 18 and 12. 1 and 1 gives us, or 10 and 10 gives us 20. 8 and 2 gives us 10. Another group of 10. 10 plus 20 gives us 30. So this would give us 30. 30 plus 20 gives us 50. 4 plus 0 gives us 4, so that gives us 54. We add those together, it gives us 84. Now we're talking area, surface area. It's 84 square yards. Square yards, or yards squared. All right? Again, that was the toughest of the 3. Ideally, you're watching this and kind of checking over your own work. All right, let's take a look at number 11. Let me get rid of this work here. Let's take a look at number 11. Again, I'm thinking about opening these up into nets. Taking that polyhedron and open up into a 3-dimensional net. Okay? 3-dimensional net. Let's take a look. Let me erase this stuff. Let's take a look at number 11. Now, number 11, as I promised, is a little bit easier. If I take a look at number 11, it's a rectangular prism. Now, if I were to trace over, this rectangle here is congruent, is equal to the rectangle on the bottom face, if you will. Okay, if I take a look, this side rectangle is congruent, is equivalent to this side rectangle. They are equivalent. Now, it's going to be kind of tough because I have all this drawing here, but we have a front face. Oh, wrong color. We have a front face, which is congruent to the back face. So the reason we could get a formula for this by doing this. Surface area of a rectangular prism. Rectangular prism is I like to do SA for surface area. You don't have to. Equals 2, because I'm going to double. If I find the area of one face, I'll double it. Equals 2 times length. I'm going to make a cursive L so we don't confuse it with a 1. Length times width. Plus, because we want to bring all these together, combine them all together. Plus 2 times the length times the height. Plus 2 times the height times the width. All right. Now, let's make this even a little easier for ourselves. I'm going to go through here and label each one of these as a length, a width, and a height. This would definitely be the height, if you want to call it the height. This could be the length, and this would be the width. It doesn't really matter what I call the length or the width or the height, as long as each one has its own label, if you will, because multiplication is commutative. And you notice in my formula here, I have 2 lengths, 2 widths, and 2 heights. Now I just go ahead and substitute those values into what I've established. So now it becomes 2 times the length, which is 7, times the width, which is 2, plus 2 times the length, again, which is 7, times the height, which is 2 and a half, plus 2 times the height, which is 2 and a half, times the width, which we called this 2. We labeled it 2. And again, notice, I have 2 7s, 2 2s, 2 2.5s. Now, some multiplication here. We're good at this. In the parentheses, 7 times 2 is 14. 14 doubled gives us 28. Plus 7 times 2 is 14. Half of 7 is 3.5. Half of 7 is 3.5. So we have 3.5 plus 14, I think gives us 17.5. 17.5 times 2, I think gives us 35. Let's just double check my math here to see if, because I haven't been teaching math in a while here, I guess, as far as in front of kids, if I can still do this mental computation. I said 7 times 2 is 14. Half of 7 was 3.5. So we have 3.5 plus 14 is 17.5, right? 17.5 double, it should give me 35. Let's double check. So we have 7 times 2.5 equals, yes, times 2 equals, oh, all right. So we get a 35 there because I doubled that 17.5. This is an ugly looking plus sign, Mr. G. Meaning. Plus, now we have 2.5 times 2. 2 times 2 is 4. Half of 2 is 1. 4 plus 1 is 5. 5 times 2 is 10. So plus 10. Let's add all these together. We have 30 plus 20 plus 10. 30 plus 20 plus 10. 30 plus, that gives me 60. We have 8 and 5, which gives me, I believe that gives me, what is that? 13. So we have essentially another group of 10 plus 3 ones. That should give me an answer of 73, and it's square meters. Square meters. All right, let's go to the last one. As I promised you, it goes from hard to easy, challenging to the easiest. We have a cube. The great thing about a cube is all the faces are congruent. And if I look at a cube, if I see that cube, I can see that all the faces are congruent, and a cube has 6 faces. So the surface area for any cube equals 6 times, if you want to do base times height, length times width, whatever, 6 times base times height. Now, if I take a look, we have 6 times, we can call the base 12 times the height, which is 12. I am essentially finding the area of one face and then finding that 6 times because there's 6 squares that make up that cube. They're all congruent. If I find the area of one of them, I just multiply it by 6. How many faces are total? 12 times 12, the last time I checked when I was here at Troy, and I'm back at Troy right now, is 144. We go 144 times 6. 144 times 6 gives us 24. 24 plus 2, I think, gives us 26, right? 6 times 1 is 6 plus 2 gives us 8. I think that's 864 square feet for that one. All right? Let's take a look at what we have. Again, hoping this makes sense. I'm trying to break it down for you. Again, it's tough when you're not in front of me, but we're doing our best. Everybody is. Let's go with the next one. We got 13. You want to wrap a paper weight shaped like the triangular prism shown. How many square inches of wrapped paper do you want to completely cover this prism? Okay, this one is going to be a little bit easier than the one we did for the last one. Because if I take a look, we know that the triangles are good. But what's nice about this one is, because this here, this is an equilateral triangle. So this is an equilateral triangle prism, if you want to call it. Meaning every single side of this triangle is congruent. They're all 4 inches, making this rectangle, and this side rectangle all having the same dimension of an 8 by 4. So again, instead of just jumping into the problem, let's analyze it. All right, now, what we have here is we have surface area, and I can almost make my own little formula if you want. The area of the triangle we know is 2 times, because there's 2 triangles, we want to wrap both sides, both triangles, 1/2 base times height. But we're going to add to that because there's 3 rectangles and they're all congruent. So I'm going to find the area of one rectangle and multiply it by 3. So 3 times, let's go length times width. All right, now we're going to substitute some values in here. We go 2 times 1/2. The base of that triangle is 4. The height is 3.5. Plus, we go 3 times length times width. Because there's 3 rectangles that are all congruent. 3 times 8 times 4. Okay, we have multiplication here. Let's take a look, see if we can do this. 4 times 3 is 12. 4 times 1/2 is 2. 12 plus 2 is 14. Half 14 is 7. 7 times 2 gives me back to 14. Plus, I'm going to do this a little easier. I like to go 3 times 4 first. 3 times 4 for me is 12. 12 times 8 is 96. I add these together. 90 plus 10 gives me 100. 6 plus 4 gives me 10. 100 plus 10 gives me 110. I need 110 square inches of wrapping paper to wrap that paperweight. All right, next one. A rectangular prism has a length of 12 centimeters, a height of 6 centimeters, and a width of 4 centimeters. Use the formula SA equals 2 times length times width plus 2 times width times height plus 2 times length times height to find the surface area. This is great, guys. All we're doing, substitution. We're great at substituting things in, and we're great at multiplying. We have that brain power to do that. We have a lot of experience with multiplication. If you watch that mindset video I showed you the other day, we have a lot of experience with multiplication. And if we practice it every day, it becomes internalized. It's firing off those synapses right now in my brain. I'm making those neural pathways much stronger to connect knowledge from all parts of my brain together, which is exciting stuff. It'd almost be great to be able to see this. It's probably like a lightning storm right now in my head. Now, they tell us the length is 12. Wherever I see an L, I'm going to substitute in a 12. So we go 2 times 12 there. Wherever I see an H, I will substitute in a 6. And wherever I see a width, a W, I'll put in a 4. So times 4 plus 2 times. That W was a 4. That height we said was a 6. Plus 2 times. We said the length was 12. I should say they told us that the width was 4. If I double check, is every number utilized twice for rectangular prism? 12 is there twice. Good. We got 4 in there twice. Good. We have 6 in there. Uh-oh. See, I found my mistake. This is, the width is 4, the height is 6. Ah, see what I did wrong with the formula? I did length times width again. I should have done here length times height. See, always good to check your work. length times height. So this becomes 12 times, not 12 times 4, but 12 times 6. Again, look at how I'm modeling that video from the other day. All right, that's a crazy 6, isn't it? There you go. All right, let's do some math. 12 times 4, 48. 48 doubled give us 96. 6 times 4 is 24. 24 doubled give us 24. 24 gives me 48. Plus 12 times 6, 72. 72 double gives me 144. I have 90 plus 40 gives me 130. Plus 14 gives me 144. Plus, hey, 144 gives us a grand total of 288. Do they give us a unit? Yes, centimeters. Square centimeters. All right. Wow, I'm tired. I think I'm sweating. I haven't worked that hard in a long time. Anyways, hope this helps you guys out. Again, sorry about the situation we find ourselves in. Remember, I had that open Google Meet. Today, I'm filming this on Wednesday, so I'll have another open Google Meet on Friday. All right, stay healthy and strong. See you.